Here we are with the Chapter 3 Individual Test Corrections video. Forgive my somewhat scratchy voice. We start with a generic rectangle problem. So I'm making my box here, 2 by 2, and I've always suggested that you put the X part of the parentheses in the bottom left corner, and then one thing that people are doing wrong is they don't put this minus with the 3, but it needs to be part of the 3. And then the other parentheses, x and 5, it is positive 5, would go on the bottom. So now what we're doing is we're always multiplying to get what's inside the squares. X times x is x squared. X times 5, right, for this box, is 5x. Negative 3 times an x is negative 3x. And finally, negative 3 times 5 meet up in the top box, and that's negative 15. Now, what I'm doing is I'm circling the like terms. Don't they both have x behind it? I don't want to put x things with x squared, but these two that I circled can go together. So my answer, x squared, these two, 5x and negative 3x, what do they combine to make, adding them together? 5 plus negative 3. That's positive 2x. And then minus 15. Those three things could be written in any order. Many of you put this first and this next and that, whatever, rearrange however you want, but as long as those three pieces are there, that's letter A. Letter B then is very much the same kind of problem. There's no negatives in any of it, which makes things a little bit smoother. 2x times x, 2x squared. 2x times 6, 12x. 1 times x, 1x. 1 times 6, 6. Here we go again. Like term there, like term there. So 2x squared from this box. What do 12x and 1x make? 13x. It is positive also. And then 6 was positive, so plus 6 in the back. Most of the errors here were just arithmetic mistakes. I think some people multiplied these two together and they put 3x squared, almost like you were adding 2 and 1 at the same time as you were multiplying. But 2x times 1x is 2x squared. It's little things like that. Now I would still suggest a box for letter C, but frankly not many people drew it, and I can see why. You don't really have to, but as long as we're good at the box stuff up here, let's just use it again down below. Negative 5x times 4x. Negative 20x squared. Negative 20x squared. A lot of folks left off that square right there. It is x times x. And in the second box, negative 5x times 3. Negative 15x. There is an x right there, right? Negative 15x. So if I'm just taking the stuff in the boxes and writing it down side by side, then there's my answer. Recorded, right? Simple as that. Number 2, given the following equation, and again, what sucks about this is it does not look like y equals like we want. This is what we're hoping for, but it's not in that form yet. We just did this together as we were getting some of our classwork done yesterday. Well, when you watch this video, it's going to be on Tuesday of this week. We did some more problems of this type, okay, where it says solve for y. Okay, watch what I do. If I want to get y alone, then the minus 8x needs to get gone, get moved out of the way. So I'll make it cancel by doing plus 8x to both sides. Watch those disappear. Okay. So what's left is 4y equals, now over here I have 20 plus 8x. Not like terms. Can't add them together. Should I write 20 plus 8x or 8x plus 20? I think writing 8x plus 20 is better because that looks more like your typical y equals mx plus b equation, right? I want the x in front and the number at the back. So I only have one thing left to do. I want to get y alone, so if I divide by 4, I divide everything by 4. I've said this a million times. Divide everything by 4. They go away. Now I have y alone. Perfect. That's exactly what I wanted. 8 divided by 4 is 2x, and 20 divided by 4 is 5. Done. What is the slope? I don't know what to say. If you don't know by now that the slope is in front of the x, you're in rough shape. Slope's in front of the x is 2. Y-intercept, back number, 0, 5. Graph the line. Okay, we know how to do that. Y-intercept first. 1, 2, 3, 4, 5, right on that little tick mark. And to say my slope is 2, of course, really means 2 over 1. So up 2 over 1, up 2 over 1, and so on. And there's my line. Like terms, combining like terms. We did some practice with this, and I kept telling you to put little boxes or circles or things like that underneath the like terms. Let's start with xy's. How about I underline? I'm going to use something from Chastity Anderson's strategy, I think, is the person that did this. So 3xy minus another xy with a 1 in front, by the way. 3 minus 1 is 2. Oh, look, here's another minus xy, minus 1xy. So if I have 3 of them, and I take 1 away, I have 2. And if I take 1 more away, I only have 1. 1xy. That's what's left when those 3 are combined. What else are like terms? Well, okay, I was going to use the underlining method from Chastity, but I think now I'll circle the next like terms. Plus 4, plus 10. Those are just numbers, right? Numbers can go together. Positive 4 and positive 10. Positive 14. I look at the 2 that I haven't touched yet. I can't put y and x together. I've used up everything else. These guys don't have partners, so just copy them. Done. Letter B. Let's see what we have that go together. 1y, right? Positive 1y. Check this out. Negative 1y. 1y minus 1y, you have no y's left. You have nothing. So even though I combine those, I'm not going to really do anything about it because they just cancel out and make 0. 5. Are there any numbers that go with 5? No. So I guess 5 is in there. Negative xy. Here's a check mark above it. Any other xy's? No. So that's part of my answer also. X squared. Box. Any other x squareds? Oh, yep, right there. Negative 4x squared. So what is 1x squared positive minus 4x squared? I'd have negative 3 of them. Negative 3 of the x squareds. All that's left is this. It's literally all that's left, so of course it has no partner. So I'll put that down, and here's my answer for B. So there were some things to combine together, but some terms just had nothing to combine it with, so they just kind of appeared in the final result. Pause, fast forward through this. I'm going to take a call from my wife. Hello? Hey. Maybe, but I got a lot of stuff to do schoolwork-wise before we leave today. So, as long as it's later, good. Maybe 5 or something. I don't care where I meet you, really, but I'm just saying, I got a little bit to do. Lock day tomorrow, I don't have prep or anything, so it kind of sucks. Sorry, back at it. You know, these tests, the front page was much more successful, unfortunately, than the back page. And I know these 3 questions right here gave people a lot of problems. It's not worth a ton of points, but you know, they were the most challenging ones. Look at letter A, solve for x. But hey, I have parentheses. I see the distributive property right here where I'm kind of waving my pen back and forth. So again, the box is just my idea for how to do these. But I can use the box to do the distributive property, multiply those 2 together. Negative 2 times 5x, negative 10x, negative 2 times 10, minus 20. So isn't negative 10x minus 20 the left side of my equation? And I still have equals 50, of course. This equation should look really normal, really easy for you now. You've solved things like this 100 times, right? Line down the equal sign, plus 20 to both sides. Negative 10x equals 70. Divide by negative 10, divide by whatever's in front of x. X equals negative 7. Done. Hey, look at letter B, more parentheses, more distributive property. So I'm going over here, I'm using my box picture, m and negative p, setting up my distributive property. 2 times m, 2m, 2 times negative p, negative 2p. Now, let's continue. 12p equals, oh look, I just got the answers from the distributive property, and I still have the plus 8 that I don't want to forget about. See what the question says? Solve for m, solve for m. So I know that I want this problem to only end when I have m equals, and everything else is on this side. Everything else. So let's see. If I want m alone, don't these 2 things have to get moved over to the other side? So what should move over first? How about the 2p? I want to cancel it from this side and, you know, put it on the other side. So I made those go away. 12p plus 2p, 14p. They are like terms. They're both p's, right? I can combine them. 2m plus 8. I'm going to move that up here. 14p equals 2m plus 8. We said we also have to get the 8 moved over, right? Minus 8, minus 8. Because I want m alone, so that needs to disappear. And I'd have, now can I combine those together? Are they like terms? No, there's no p here. So 14p minus 8 equals 2m. Remember the problem on the other side where we had to get y alone? And so here, if we have to get m alone, I need to divide by 2. But what gets divided by 2? Everything. Just like the problem on the other side of this test. Everything. 2's cancel. M equals 14p divided by 2. Let's see. 14 divided by 2 is 7p. Negative 8 divided by 2, negative 4. So my m is 7p minus 4. So when I solved for m, I didn't get m equals 3, right? M equals 8. I had p in my answer, but it still is the goal of the problem because I do have m alone, and that's all I really had to do. Letter C. I'm sorry to say this, I cannot believe how people continue to forget that when you see absolute value in an equation, that you have to separate the problem into 2 different things. You take the bars off the left side, and you make it equal regular 21, and then you take the bars off and make it equal negative 21. We're going to get 2 answers. 2 answers. They're both very easy to solve. Come on. Plus 7, plus 7. 4x equals 28. Divide by 4. X equals 7. 1 answer. I'm pretty much doing the same steps over here. It's just that when these cancel here, and now I do negative 21 plus 7. Negative 21 plus 7 is negative 14. And yes, when I do divide by 4, that's not a really great answer, right? But I've told you a million times, leave it as a fraction. If you want to reduce it, terrific. If you want to make it a decimal, I don't care. But you didn't have to do any of that last stuff. You could have just left it like this as a fraction. And it's done. Two answers, because you take the bars off, and it's positive 21, negative 21, solve them both. For these exponent ones, it's really about memorization, isn't it? I don't know what else to say about these. Problem A is a rule that I taught you that you add the powers together. 5 plus 7 is 12. B looks different than A. Different rule then. On one like this with parentheses, you multiply them together. All C is like A with two different letters. Why don't we take the K's and do the adding of the powers trick like we did up here. 8 and 10. 8 plus 10 is K to the 18th. And then I'll do the same thing with the M's. Now doesn't this M right here with nothing really have a 1, of course? So 3 plus 1 is M to the 4th. This rule is dividing things, right? But the exponent law says that you subtract the powers. 20 minus 2. 20 minus 2 is 18, not 10. What can I say about E? How many times have I said anything to the 0 power is 1? The end. This question was just like on the team test, just like on the chapter summary. If you have a negative exponent, you write it as a positive exponent and you put it under a 1. Nothing here is anything more than just memorizing the rule to use. G. G and B look a lot alike, don't they? Parentheses and all that. So here's the deal. When it comes to the x's, I want to do the multiplication just like I did up here. So x 6 times 2 is 12. Y 14 times 2 is 28. There were a lot of people who put 3 here in front because they just took the 3 and copied it. But it's not 3. It's 3 squared, isn't it? See, the 3 has the square that goes with it also. What's 3 squared? 3 times 3. 9. You knew that. H. Does H and B look a lot alike? Parentheses, right? So what do I do first with these two? Multiply them. X 30 times x to the 7th. Some people left the question like this. How could you leave it like this when you know that, like, if you look at letter A, it's the same style of exercise, and I want to add those powers together to get x to the 37th. Got to take it that far. That far. I know this extra credit was hard. Here's what I'm going to say about it. We end up learning a way, a method for taking apart equations like this. These are called quadratics, right? These are called quadratics. So we learn an official way to dismantle these, to break them apart into their original parentheses. Since you haven't learned that yet, that's why I thought it was fun extra credit, because a lot of you had a scratch paper and it was just filled with box pictures all over the place, right? You were trying 3, 4, 5, 8, 10 times, and eventually some of you got it and eventually some of you didn't. It ends up being 3x, let me see, 3x, I can't remember myself, plus 1, no, I don't want to have to look at somebody's paper to find the answer. I should be able to do this on my own. It's Okay. Plus 1 and minus 3. Yeah, this is definitely it. Okay, that combination right there. You could have these things in the parentheses reversed, and it's still fine, but you have to have exactly those two things in the parentheses. If you'd like to prove that this is right, then make a box picture and put the things on the outside and fill in the blanks and prove that you get this result. I guarantee you that you will. Some of you were close, but for extra credit, I had to have those two things in there perfectly, and that's what it ended up being. All right, thank you.